Question 13. What are the design verification guidelines? Answer. Design verification guidelines use all audits and analysis aids possible to help find potential design bugs, investigate and correct all errors, warnings, simulate thoroughly but use stimuli that eat their way into the design, testing one function at a time, more important for complex circuits. When circuit doesn't work, see what works and what doesn't to narrow down the search space for the problem, which outputs work, which outputs fail and under what conditions. Monitor lots of internal nodes. Additional simulations with different vectors can be helpful. Remember, debugging is just solving out a puzzle. Also, if something doesn't look right, stop and check it out. Don't overlook potential bugs. Always rerun audits and simulation after correcting any problem or after any changes. Another bug could be lurking, or the fix may have messed up something else. Question 14. What are sequential logic design steps? Answer. Sequential logic design steps derive circuit state diagram from design specs, create state table, choose flip-flops D, T, SR, JK, create circuit excitation table, use flip-flop excitation tables, construct K-maps for flip-flop inputs, primary outputs, obtain minimized SOP equations, draw logic diagrams, simulate to verify, design and debug as needed, perform circuit analysis and logic optimization. Question 15. Explain about program counter. PC. Answer. The program counter is another specialized register. It keeps track of the execution of a program. It contains the memory address of the next instruction to be fetched and executed. During the execution of an instruction, the contents of the PC are updated to correspond to the address of the next instruction to be executed. It is customary to say that PC points to the next instruction that is to be fetched from the memory. Question 16. What are memory address register (MA) and memory data register (MDR)? Answer. These two registers facilitate communication with the memory. The MA holds the address of the location to be accessed. The MDR contains the data to be written into or read out of the addressed location. Question 17. Explain the operating steps for program execution. Answer. Operating steps for program execution. Programs are stored in the memory through the input unit. Execution of the program starts when the PC is set to point to the first instruction of the program. The contents of the PC are transferred to the MA and a read control signal is sent to the memory. After the time required to access the memory elapses, the addressed word, in this case, the first instruction of the program, is read out of the memory and loaded into the MDR. Next, the contents of the MDR are transferred to the IR. At this point, the instruction is ready to be decoded and executed. If the instruction involves an operation to be performed by the ALU, it is necessary to obtain the required operand. If an operand resides in memory, it could also be in a general-purpose register in the processor. It has to be fetched by sending its address to the MAR and initiating a read cycle. When the operand has been read from the memory into the MDR, it is transferred from the MDR to the ALU. After one or more operands are fetched in this way, the ALU can perform the desired operation. If the result of the operation is to be stored in the memory, then the result is sent to the MDR. The address of the location where the result is to be stored is sent to the MAR, and a write cycle is initiated. At some point during the execution of the current instruction, the contents of the PC are incremented so that the PC points to the next instruction to be executed. Thus, as soon as the execution of the current instruction is completed, a new instruction fetch may be started. In addition to transferring data between the memory and the processor, the computer accepts data from input devices and sends data to output devices. Thus, some machine instructions with the ability to handle I/O transfers are provided. Question 18. What is an interrupt service routine? Answer. Normal execution of a programs may be preempted if some device requires urgent servicing. For example, a monitoring device in a computer-controlled industrial process may detect a dangerous condition. In order to deal with the situation immediately, the normal execution of the current program must be interrupted. To do this, the device raises an interrupt signal. An interrupt is a request from an I/O device for service by the processor. The processor provides the requested service by executing an appropriate interrupt service routine. Because such diversions may alter the internal state of the processor, its state must be saved in the memory locations before servicing the interrupt. Normally, the contents of the PC, the general registers, and some control information are stored in memory. When the interrupt service routine is completed, the state of the processor is restored so that the interrupted program may continue. Question 19. Discuss various parameters for improving the performance of a computer. Answer. The most important measure of the performance of a computer is how quickly it can execute a programs. The speed with which a computer executes programs is affected by the design of its hardware and its machine language instructions. Elapsed time, I. The total time required to execute a program, E. This elapsed time is a measure of the performance of the entire computer system, E. It is affected by the speed of the processor, the disk and the printer. Processor time, I. Here we have to consider only those periods of the elapsed time, during which the processor is active. 2. The sum of these periods is called processor time. 3. The processor time depends on the hardware involved in the execution of individual machine instructions. Cache memory, I. The processor and a relatively small cache memory can be fabricated on a single IC chip. 2. The internal speed of performing the basic steps of instruction processing on such chips is very high and considerably faster than the speed at which instructions and data can be fetched from the main memory. 3. A program will be executed faster if the movement of instructions and data between the main memory and processor is minimized, which is achieved by using the cache. Question 20. Explain various components of system software. Answer. Compiler, a system software program which translates the high-level language program into a suitable machine language program. Text editor, another important system program that all programmers use is a text editor. It is used for entering and editing application programs. The user of this program interactively execute commands that allow statements of a source program entered at a keyboard to be accumulated in a file. Operating system OS, it is a key system software component. This is a large program, or actually a collection of routines, that is used to control the sharing of an interaction among various computer units as they execute application programs. The OS routines perform the tasks required to assign computer resources to individual application programs. These tasks include assigning memory to program and data files, moving data between memory and disk units, and handling I/O operations. Question 21. Explain the role of system software in a computer. Answer. System software is responsible for the coordination of all activities in a computing system. System software is a collection of programs that are executed as needed to perform functions such as 1. Receiving and interpreting user command. 2. Entering and editing application programs and storing them as files in secondary storage devices. 3. Managing the storage and retrieval of files in secondary storage devices. 4. Running standard application programs such as word processors, spreadsheets, or games, with data supplied by the user. 5. Controlling I/O units to receive input information and produce output results. 6. Translating programs from high-level language to low-level language. 7. Linking and running user-written application programs with existing standard library routines, such as numerical computation packages. Question 22. Explain how timing differences are smoothed out among processors, memories and I/O devices. Answer. The devices connected to a bus vary widely in their speed of operation. Electromechanical devices such as keyboard and printers are relatively slow. Others like magnetic or optical discs are considerably faster. Memory and processor units operate at electronic speeds. 1. A common approach to smooth out the timing differences is to include buffer registers with the devices to hold the information during transfers. 2. They prevent a high-speed processor from being locked to a slower I/O device during a sequence of data transfers. This allows the processor to switch rapidly from one device to another, interweaving its process activity with data transfers involving several I/O devices. 3. Thus, buffer registers smooth out timing differences among processors, memories and I/O devices.